Hello, welcome back to Dinosaurs. Welcome to the final week of Dinosaurs. We're halfway through Module 5. We're going to start talking about Eurasian dinosaur sites today. Talk about the Gondwanan, the southern continent dinosaur sites on Wednesday. And then on Friday, we're going to finish up with dinosaurs in pop culture. Before we do that, though, some announcements. You should be able to calculate out your grade down to the nearest decimal point, but you need to use that formula. I can't calculate out everybody's grade here. There's 150 people in the class. Just look at the syllabus, get that formula, and plug in your grades. Anyway, let's review. So why are the Triassic dinosaur sites somewhat limited? So we started talking about North American dinosaur sites last time, and we started with Ghost Ranch. Ghost Ranch was a Triassic dinosaur site, and there aren't many other examples. So why is that? So take a look at the options there. Why might that be? So try to remember what's going on during the Triassic. If we look at these Triassic forms here, it's not just the dinosaurs that are around during the Triassic. So there's kind of a shift towards the end of the Triassic where dinosaurs start becoming a little bigger and a little bit more diverse with the Carnian pluvial event, but dinosaurs really don't fully start increasing in body size and diversity until we get into the Jurassic. And so for the most part, Triassic dinosaurs are relatively restricted. We saw the coelophysids in Ghost Ranch. We're going to see some Dilophosaurids today from some European sites. But there's not a lot of Triassic dinosaurs in the rock record. It's not because there's no Triassic rocks, it's because there was a lot of competition around and dinosaurs just hadn't become all that dominant and all that common. It's not that dinosaurs had not evolved yet. There are a few forms, and it's not that they haven't been discovered yet. Geologists have been all over the world. I'm sure there's others that we will discover, but we've certainly uncovered most of it. And then how can geologists reconstruct the environments of the past? So I spent a lot of time last lecture, and we spent a lot of time earlier on in the course, talking about ways that geologists are able to read the rock record. So all of those sedimentary layers are like pages in a book. And if you know how to read the book, you can get the story and reconstruct the story. Although remember that a lot of the pages are torn out, a lot of sentences are crossed out, there's a lot of missing information. But just like with a novel, if you skip a couple chapters, you can probably piece together what happened, as long as you have the main plot points there, which that's kind of what we have to do. We have to try to piece together the geologic past from scattered information using the context that we do have, and try to fill in the gaps like forensic scientists. So what are some of those things that we can look at? Hopefully this one's fairly easy because random guessing is never the answer. We wouldn't have a science class about random guesses. Everything that I've been teaching about in this class, everything we've been covering, everything we've been talking about, remember there's a fairly high chance that a lot of this information is going to be replaced in the future by better information. This is the best knowledge that we have at the time, based on what we know now, and based on the interpretations that we're making now. As we get new information, we'll get better information and we'll draw to better interpretations. That's how science works. Science is this process of making interpretations and testing interpretations, not making wild guesses and just retaining those wild guesses. It's not random guesses. So if we're trying to reconstruct an ancient environment, we can look at grain size. Remember, there's a rough correlation between grain size and energy. Large grain sizes like gravel takes a lot of energy to move. So you might find that at really wave-beaten beaches or large, very high velocity, high stream flow rivers, sedimentary structures, different flow structures make different kind of marks on the rock. A good example are these ripple marks up here. And then also fossils. So if we find a bunch of clam fossils, a bunch of seashell fossils, we know that it's probably a marine environment. If we find a bunch of dinosaur fossils, we know that dinosaurs are terrestrial animals. And so we know that it's a terrestrial environment or maybe they were washed out to sea or buried in a river. But we can read these rocks. So this is a modern day deposit here. This is rock that's still sediment that was maybe literally deposited like yesterday. You see the ripples here. You see how there's a shallow side and a steep side. The water was flowing this direction. So it was a unidirectional flow, probably a river. And you see that a bird came and made birdie prints through there. We can tell which way it was headed. If you're good with it, you might even be able to tell what kind of bird. In this case, it was probably a seagull or maybe a goose. But we can do the same thing with dinosaur prints. Here's an ancient, at least 66 million year old rock. We see the ripples in here. We can actually tell which way that ripple, the current was flowing that deposited those ripples, and we see the tracks. And again, if we're really good, we can figure out who made those tracks and the trace fossils. So again, it's not random guessing. We can look at all this different evidence in the rock record to try to piece together the geologic past. All right, so let's talk about some Eurasian dinosaur sites. We're going to start in Europe. And one of the assumptions that I made when I was putting together the course schedule is that, oh, well, it was really easy to put together a list of North American dinosaur sites. In fact, I had to leave out some really good North American dinosaur sites. And I found a lot of detailed information on those. And I sort of made the assumption that when I get into talking about Eurasian dinosaur sites and Gondwanan dinosaur sites, that it's going to be the same thing. But what I found is that that's not entirely true. So we're going to see a little bit less detail today than we did last time. Maybe you like that, maybe you don't. But we're going to start with Europe dinosaur sites, and there's sort of a reason for that. If we think way back to earlier in the class, dinosaurs as a group are thought to have originated in either South America or Africa. That's where we find the earliest evidence of dinosaurs, and then they very quickly kind of radiate outward from there. We saw lots of North American dinosaurs. We see good evidence of Triassic dinosaurs like Coelophysis all over North America. Even in New York State, down in southern New York State, we get those three-toed dinosaur fossils, probably Coelophysis fossil, trace fossils. And at that time, the dinosaurs went through North America, they went through Europe, and then to get to Asia, they needed to go through Europe. So Europe is acting as this gateway to Asia. And so we see quite a lot of Triassic dinosaurs in South America and Africa into North America, relatively few in Europe, and then really kind of almost none in Asia. So we're not actually going to even talk about a Triassic Asian dinosaur site. There's very limited material from there. And we'll see that there's really not that much material from Europe either. One thing that is found in the Black Forest, Germany, down in the kind of Swabian area as well, we find this massive herbivore, Plateosaurus. And if you remember back to the sauropod lectures, Plateosaurus is the first dinosaur that really takes over one of these large niches. So it's the first dinosaur that's the dominant herbivore role. It's filling this large herbivore role. And again, it's the largest dinosaur from the Triassic. In Germany and surrounding areas as well, we also find Lylum sternus, which it looks a lot like a Dilophosaur here with the head crest. It's an early one of these forms, and it's probably transitional from Coelophysis to Dilophosaurus, and it's sometimes reconstructed a little bit more Coelophysis-y or a little bit more Dilophosaurus-y. The skull crest isn't actually known, so it's sort of an interpretation based on its ancestry. It's one of those hypotheses that we're making from its evolutionary history from the inferred cladogram. We see some of these other creatures that are around at this time, some amphibians, very early forms of turtles, and so on. So this is Black Forest dinosaurs. Where it all began in England. I think I messed up here, the early Cretaceous Jurassic coast. It's mostly Jurassic, I'll try to fix that, of southern England. It provides a wealth of fossils here. So the southern shoreline of England down here, all kinds of marine Jurassic fossils, lots of ammonoids. And you see this is an outcrop of the Wessex Formation. along southern England. All kinds of fossils in here. Again, you can see kind of the reddish tint. Reddish tint is a big red flag for geologists. It means that the rocks have rusted. They're probably terrestrial deposits. Terrestrial deposits are great places to find dinosaur bones, since dinosaurs are terrestrial animals. You see in the background here, there's the white chalk that you would find at the cliffs of Dover. This is the Isle of Wight here with the chalk here. Those chalks are made of marine fossils. Dinosaurs are not marine animals, so not so much from the marine chalks here, but lots of other marine fossils from there. This Wessex formation also correlates with the weld clay a little bit farther to the east. And what I mean by correlate is it's up like same age and sort of a very similar geology. And again, it's mostly mudstone, which is shale, so really fine-grained stuff, implying a rather low depositional environment. So kind of calm water, like a lake or a pond or something like that, or a very shallow marine. And it's interbedded with red sandstones. Again, sand, the implication is that it's a little bit higher energy, and red is that it's terrestrial, so this is probably river environments here, again, mostly from the south of England. And that's where dinosaur paleontology really got its start. So Richard Owen named the Dinosauria in 1941-42, depending on whether you decide the informal or formal first use. But he based, remember, on the big three, the original three: Megalosaurus, Iguanodon, and Hylaeosaurus. Iguanodon reconstructed behind me with the Crystal Palace dinosaurs. These dinosaurs were found in formations like this. And so this is what it kind of looks like in the present. What did it look like in the past? So as the Wessex formation was being deposited, as the weld clay to the east were being deposited, this is what Europe looked like. So Europe was an archipelago, a series of little islands. You can see the modern day boundaries are on here as reference point. Here's England. Most of the southern England is in kind of very shallow water. Remember, dinosaurs are not marine animals, so at times this was drier than this. This is kind of what it looked like, a shoreline kind of coastal environment, lots of water, kind of a big floodplain environment. And dinosaurs sort of had to kind of island hop across Europe, and they definitely did so. So to get from Africa through Europe into Asia, they had to kind of get through this series of islands, and they were able to do that fairly well. Again, sea levels are rising, sea levels are lowering, sea levels are rising, sea levels are rising. Sometimes these islands are connected, sometimes they're not. But you see a lot of the big modern sedimentary basins like the Paris Basin, some of these other bases here in Switzerland, they're entirely underwater. And so we have marine deposits there, and the dinosaurs are sort of on this land. And so the fossil record in Europe of the dinosaur days is sort of broken up and sort of sparse. So what you're going to see today is that there's a little bit less detail than what we had for North America. People have been working in the North American dinosaurs since the Bone Wars in the 1850s to 1870s into the 1800s, and then obviously through to today. And so there's a long history of dinosaur paleontology in North America, and there's also really good exposures in North America. We see that, so there's a long history of dinosaur paleontology in Europe as well, but we don't have that wealth of very large exposures, in part due to this ancient geologic history here with these broken up areas where dinosaurs could live, but also because of technism related to the Alps and the collision. The rocks have been buckled and folded and eroded, and so the record is a little bit more incomplete and a little bit harder to piece together. And so that's why we have a little bit sparser record in Europe. We're going to move into talking about Asian dinosaurs. There's lots of good Asian deposits of dinosaur-bearing formations, but it doesn't have that long track record of paleontology working on it. And so we're going to see sort of a lack of information today for kind of two different reasons. One, the rock record sort of incomplete in Europe, and two, the like paleontology analytical record sort of incomplete in Asia. So what are some famous dinosaurs from the Wessex Formation. Probably most famous of all is Baryonyx, the Spinosaurid. So it's a megalosaur, iguanodon with its big old thumb spikes that were mistaken for nose spikes. Neovenator, one of the carnosaurs. And we also have some other Palocanthus, one of the earlier armored dinosaurs. In this case, it's a nodosaur without the armored club tail, although you can't actually see that there. And then they've included some of the marine reptiles on here for good fun, and then even some of the fish and some of the crocodilomorphs on here. And you also see some pterosaurs that have been found in this formation as well. Obviously, these reconstructions here are not quite as, let's say, scientific as some of the other ones we've seen before. And I think that just goes to, it hasn't been the center of a lot of paleo art reconstructions because there's a relatively scant fossil record here. There's a lot of incompleteness. We don't have these massive dinosaur-bearing formations like we do in the Western United States. But some other European dinosaurs that we see from other formations, again, here's Megalosaurus, one of the originals, Torvosaurus, one of the bigger carnivorous dinosaurs from Europe. Do have the record of some larger herbivorous sauropods. We already talked about Neovenator. We already talked about Iguanodon, Baryonyx, the Spinosaurid here. Some hadrosaurs, some of the armored dinosaurs here. We don't have the complete record though, and we really don't have the kind of evidence that I was kind of looking for to support the interactions like we did on the last slide. So it's really hard to build like a picture of a complicated dinosaur food web and how they might have interacted when we don't really have as much material and as much runtime on the science as we do in North America. So anyway, these are some other European dinosaurs. So now we're going to shift into Asia, specifically in this case, China. The Dashanpu formation is mid to late Cretaceous, and these outcrops were discovered by a Chinese energy company in the 70s, but obviously it was known to locals kind of well before that. But it's called the Dashanpu formation, but it's actually really kind of a group. And it includes the Shishimao formation, Zhenchuchong formation, and Zailujing formations. And again, like if we look at the kinds of rocks that are making up this formation, and we look at how they're stacked on top of each other, what the shapes are, what the grain size is, what sedimentary structures are present. In this case, we see a lot of purplish, reddish mudstones. Again, red, the significance is that it's terrestrial. And then there's also some coarser material that probably represents rivers, so fluvial sand deposits with the channel cuts and a little higher energy cross stratification. Again, if we know how to read the rocks, if we know how to read the grain size, if we know how to read the sedimentary structures, we can kind of piece together these environments. But I really struggled in trying to find like paleo environment maps like I had for the Morrison and the Hell Creek. And again, it just speaks to this is several decades of work in this area, and really only since the 1990s, intense work here. So it's a couple decades versus a couple centuries, 2 centuries of work in North America, 2 centuries of work in all those sparse outcrops in Europe. But Dashanpu area is located here in Sichuan province in kind of south central China. Good seasonal, nice weather here, and just some absolutely extraordinary exposures. You see, this is a really cool way they've actually integrated the outcrop right into the museum, kind of built a museum around it so people can kind of see what these things look like in place. Just a absolutely phenomenal, fantastic example of how to build a museum. So that's what it looks like in the present. What did it look like in the past? So it's a lot of river and lake deposits. Again, kind of sandier material with the rivers, a little bit muddier stuff with the lake deposits. We also see lots of dinosaurs, so that's obviously terrestrial. but there's also a lot of crocodilomorphs, fish and turtles, which is kind of pointing more towards lake and river, so some kind of freshwater environment. And what we see is that a lot of times the dinosaurs are swept up and very quickly preserved in these river sediments. So although the dinosaurs are living on dry land, they're obviously visiting the rivers from time to time to get a drink or gather socially. And a lot of times they're swept away or they die near the river and they're washed away. A good way to preserve a dinosaur fossil is to very quickly bury it before it can be scavenged and torn apart and broken up by the elements. And so we see these dinosaurs very well preserved in these river sediments here. This is, like, again, these reconstructions are a lot harder to find. The quality here is pretty poor, but we see there's these faults kind of surrounding this basin. There's a down drop here in the basin with some watery areas here in the middle, and then some river features kind of moving there towards it. And again, we find a lot of the dinosaur fossils in the fluvial river sediments, and maybe a little bit less so out in lake sediments, but a really good place to preserve dinosaurs. And so we see a lot of different forms preserved here. So what kind of dinosaurs do we find in the Dashanpu formation? If we look at the dates, it's a little bit earlier than North America's Morrison formation, but we're seeing a kind of a fairly similar suite of dinosaurs. We've got the early kind of spikier stegosaurs. So remember, there's that trend towards kind of larger body size stegosaurs, and then also a trend away from spikes towards more plates. These are kind of earlier forms. We've also got some really large sauropod dinosaurs here. Mamenchisaurus is one of the longer necks. You see the neck is about the same length as the body and tail put together, so sort of this weirdly long neck. We also see some carnosaur forms down here, Yangchuangosaurus, so some large carnivorous predators in this environment. But really, mostly we just see a lot of sauropod stuff. And you see there's this attempt to kind of break Mamenchisaurus genus into a bunch of different species. Same thing going on here with Homosaurus. You know, maybe these are different growth stages. Maybe these are examples of sexual dimorphism. Maybe they actually are individual species, but they didn't feel comfortable enough to reconstruct them all individually for this particular piece. But again, this is kind of showing the diversity of these dinosaurs present in this formation. A little bit lesser known than the Morrison. Probably with work continuing, we'll kind of get to that level of knowledge, but still actively working. The next one we're going to talk about is the Yixian formation, again in China. It's early Cretaceous in age, and up here we've got, it's up here in the northeastern portion of China, sort of very close to the Korean Peninsula, close to Japan. This area of China was actually occupied by Japan from 1933 through to 1945, to the end of World War II. And Japanese scientists were working in the area, and they noticed, you know, oh, there's these dinosaur fossils and some other fossils in the area, but their contribution sort of vanished over time. Obviously, there was a lot going on with the war, and there were a lot of war crimes committed in this area. It's a pretty grim portion of human history here. After the war was over, Chinese scientists rediscovered these fossils, but they really weren't excavated or worked with until the 1990s. You can see here's some excavations going on here. So again, it's not that Asia doesn't have a lot of dinosaur fossil areas. There's extensive areas of fossil exposures in Asia, and particularly in China. But we've only got about a couple decades of work on here. And so the acceleration, the discoveries are really accelerating kind of exponentially. And we're getting all of these really neat dinosaur formations out of China, particularly feathered dinosaurs, which we'll really talk about with the next one. But again, it just kind of speaks to, we've really only been working on these in great detail since the 1990s. So this is what it kind of looks like In the present, again, you see kind of seasonal temperate climate. In the past, again, this formation's pretty poorly documented. There's not a lot of literature to be found on this formation, or at least found by me. And again, that may be like a North American bias. The literature may not be translated and accessible to me as a North American researcher. Obviously, that's a limit of me, not of the research itself. But regardless, there's only been 3 decades of work on here. There's a lot more that needs to be done in this area. All those analysis of like grain size, distribution, sedimentary structure, relationships, stacking patterns, all that really needs to still be done here to kind of reconstruct and put together the paleo environment. It's not an easy process. It looks easy on North America because we've been doing it for 150, 200 years. That work's been done over and over and over again by decades worth of scientists tromping around on all the rocks, and we're just not to that point in the maturity of the science here. But again, one of the things that really sticks out from this formation and other Chinese formations is just a wealth of feathered dinosaurs, including the largest known feathered dinosaur, Eutyrannus, so a very close relative of Tyrannosaurus rex. And it was probably fully feathered, or at least very feathered. And then we see some of the smaller feathered forms too. Another thing that this records is actually a lot of the early kind of mammals, and you see they're kind of burrowing down in. Again, throughout the course of the Mesozoic, our ancestors, the early kind of proto-mammals, were kind of mostly nocturnal, mostly smaller in size, mostly burrowing and kind of, again, living in the shadows of the dinosaurs. And it's not until after the asteroid impact, not until after the dinosaurs go extinct, that the mammals are able to kind of expand out from this sort of limited diversity to the diversity that we see today. And we've also got a lot of extensive record of pterosaurs in this area as well, but kind of a reconstruction here of what it sort of looked like. These red lines are faults, and so the faults are dropping down this basin. That's kind of a story that we'll see a lot with a lot of these dinosaur sites, is that you need to have a sedimentary record to preserve the rocks, and you need to have a sedimentary record to preserve the fossils. And one way that you're able to build up a thick sedimentary record and not have it be washed away and eroded away is to make a downdrop, to make a hole, and sediment fills in that basin, and it records the geology and biology over time in that basin. So like in New York, the Newark Graben is the only area where Triassic sediments are preserved because it was downdropped by these faults on both sides, making a low. This is what's happening here. You can see Quaternary River deposits here. So that's modern river deposits. But if we rewind to the ancient environment, it's probably fairly similar. There's lots of evidence for conifer forests, ginkgos, lots of plant fossils surrounding freshwater lakes. There's also a series of ash deposits in here showing that volcanism is active nearby. And again, mostly feathered dinosaurs that we see here. So what are some of the dinosaurs that we find in this area? Again, the big old sauropod dinosaur here, some pterosaurs, feathered Eutyrannus here, Psittacosaurus, that basal ceratops is known from this, bolong, another one of the transitional basal ceratopsians. But then all these smaller feathered forms, and some even like early bird forms like Confuciornis, and Sinosauropteryx is another one of these finds in this group. The one that we talk about with the evidence for feathers, where you can even see the colored banding here, but again, maybe not quite as scientific, the drawings here, but it just gives you a good idea of how many dinosaurs are found there, and the kind of really wide diversity of forms that are seen here. And with more exploration and with more analysis, we'll probably come to know even more of these formations. And then the last one we're going to talk about today, so it's going to be a little bit of a shorter lecture, the Flaming Cliffs in Mongolia. So why is it called the Flaming Cliffs? Well, it's a pretty cool name, but At sunset, these red sandstones, the local name for it translates to red cliffs, but we came in and gave it its new name. Again, sort of this heritage of colonialism in paleontology. It's called the Flaming Cliffs, named by Roy Chapman Andrews on those Central Asian expeditions. So I showed some slides from this earlier. The big caravan of camels, and even trying to work with like very early cars on here, out in the middle of the Gobi Desert. This is a very remote, very desolate location, very difficult to get to. And so it was only really from these like 1920s expeditions that we have a lot of material from. And then this area was actually closed to foreign scientists from 1930 all the way to 1990. So again, there's extensive material here. As you can see by the arid kind of badlands topography, there's lots of rock available. It's just that there hasn't been a lot of research on here in the last, up until like the last like 30 or so years. So, and also it's just logistically very hard to get to. It's one of the most remote dinosaur sites on Earth, kind of plopped right in the middle of the Gobi Desert. Very dry, very desolate, because it's kind of in the middle of the massive Asian continent. But again, like the dinosaur bones and the very first dinosaur nest was discovered here on those Central Asian expeditions. But again, they were well known to the locals long before that. And there's even evidence of like the paleo peoples of the area using dinosaur eggshells as necklaces and things like that. So we often say like discovered when the first Europeans or Americans actually worked on it, but it was well known before that. And so kind of try to keep that in mind. And then if we talk about the past, unlike a lot of our other sites that we've talked about, the Flaming Cliffs of the present is probably pretty similar to the Flaming Cliffs of the past. At present, Mongolia is internal to Asia and really far away from moisture. The Himalayas is a recent, since past the dinosaurs, now it blocks more rain, so it's probably a little bit drier today than it was, but it was pretty similar to that in the geologic past. So the Jachta formation, it records here climatic deserts. It's an arid desert climate. How do we know that? Well, we see very large scale cross-stratified sands. When you see really large, like meter plus scale cross-stratified sands, you also see frosted quartz grains in there. That's stuff that we see in modern desert environments. And so present is the key to the past. That's stuff that we would expect to see in ancient desert environments. And so we got a lot of sand dunes. Sometimes there's like scattered areas of a little bit like muddier, a little bit wetter, probably like dried up playa lakes that sort of are alternately wet and dry up. And arroyos are these like occasionally, they're like these ephemeral rivers that sort of come and go. When it rains, they're there. When it doesn't rain, they're not. These are very common out west in the United States. Also really big sources of flash floods. If you've ever seen videos from that, you can go from a dry riverbed to a raging flash flood torrent in minutes, and dinosaurs would be caught up in that. And so a lot of these very well preserved dinosaur massive bone beds are from these flash flood events. And the other thing that's really interesting about the Flaming Cliffs is that it records abundant nesting sites, some of them even with juveniles. This is where that oviraptor nest came from, the first known dinosaur nest. And remember, oviraptor, the egg thief, it was thought to be stealing these eggs because they were thought to be Protoceratops eggs, but they're actually oviraptor eggs. And so rather than stealing these eggs, oviraptor was protecting these eggs. This actually is a Protoceratops nest. So again, this basal earlier ceratops form, you can see the smallish frill at the back of the neck here. There's like 15 individual juveniles preserved in this individual bed. They're not embryos, so they're past the embryonic stage. They're hatched, so they're relatively newborn, but they're younger, or sorry, they're older. and they're still in the nest. So again, this is evidence of like this kind of active parenting. If they're still in the nest, something is supporting them. There's some amount of parental care going on here to support these juveniles that are relatively recently hatched. And again, we see some diversity here in the dinosaur forms, feathered kind of Deinonychosaurs and some hadrosaur herbivores. And so looking at the fauna of the Flaming Cliffs dinosaurs, this is about the time period. It's a little bit earlier, but it's getting close to the time period of the Hell Creek Formation that we talked about earlier in North America. Remember, the Hell Creek goes all the way up to the very end of the Cretaceous, right to the second that the meteor impacted. This is a little bit before that, so it doesn't record all the way to there, but we see a lot of the same fauna. We see a lot of the large hadrosaur dinosaurs. We don't see, there's a speculative sauropod present. Again, we see Proteroceratops and Oviraptor present in here. That's where those nests came from. Velociraptor is in these deposits. Again, Velociraptor is much smaller than depicted in Jurassic Park, but one of the cooler fossils that's ever been found is this Velociraptor sort of fossilized along with the Protoceratops. So did they just happen to be swept away in the same flood, or were they actively engaging with each other when they were buried by a landslide? We don't know, but this fossil is often reconstructed in a position where they're actually kind of fighting with each other, and the Velociraptor is trying to prey upon the Protoceratops. And I guess we'll never know who won. The fight ended before it could be decided, when they both sort of were buried alive, probably. And then also in this formation, no bones, or maybe limited bones. There's some large tyrannosaur present here, so we don't actually see this, but we know that it's there. There's evidence of this being here, and it wouldn't really be a complete food web without having a large apex predator present. It was probably Torbosaurus or maybe Zhucheng tyrannus, but something was probably present here. And again, as we work up these deposits more, as we spend more time digging up fossils, analyzing sediments, our knowledge of these formations will increase, and we'll be able to kind of make a larger story. So again, I kind of apologize for the relative lack of detail in these lectures. I thought that information would be just as available as North America, but it was actually sort of eye-opening for me to try to put this together, and I won't make that mistake again. So anyway, this is Eurasian dinosaur sites. I hope you enjoyed that. A little shorter than most, so it saved you some time, and I will see you next time. Goodbye.